We're going to look at a new way of measuring angles called radians. So we're going to start by considering a unit circle, which is a circle with a radius that's equal to 1. Now, we're going to consider not just the circle, but the circumference of that circle, which is the distance around the outside. Now, you'll be aware that the equation for the circumference is c is equal to 2 pi r. Now, seeing r is equal to 1, then the circumference for the circle is 2 pi times 1, which is just equal to 2 pi. So again, the distance, if I start here and calculate the distance right around the outside of that unit circle, then we can say it has a distance of 2 pi. So if I wanted to do a smaller amount, so let's say I wanted to calculate what the distance was from there to there, and by the way, that's called arc length. So we say S is equal to arc length, and an arc is the distance between 2 points on a circle. So if I consider going from there to there, then that's called that arc length. Now, if the full distance around is 2 pi, then a quarter of the distance then, so S for this is going to be 2 pi divided by 4, and when we simplify that, we get pi over 2. So it's just another way of thinking about the circle and introducing this idea of arc length. Okay. But I want you to see that the angle, if you like, at the center of the circle for that arc is 90 degrees. So we kind of see that when, let's make a little table down here. So when, all right, theta, we'll make that is equal to 90 degrees. S, the arc length then is equal to pi over 2. So let's keep going a little bit, maybe do another one. I'll take this one out now. So we've seen that. So when the angle at the center is 90 degrees, which gives us a quarter of the circumference or that arc length there, that's equal to pi over 2. So let's consider a new situation. Let's say that now what we're doing is we're going to go halfway around. All right, so therefore the angle in the middle is 180 degrees. And if now S is equal to 2 pi, and it's going to be divided by 2 because it's half. Remember, 2 pi's are all the way around, so my new circumference or my new arc length is this one over here, that red line. Then we can see that's just equal to pi. So we can continue here. So when theta is equal to 180 degrees, S is equal to pi. So we're just looking at arc length. Let's try another one, and I'll leave the calculations sort of here so you can go back and have a look at them, but I'll take this out, take that out. So this time we'll have a look and see what about if I get an angle of 60 degrees, then what is the arc length there? What's S that we've got there? Now, 60 degrees goes into 366 times. So therefore that little length there is going to be 2 pi divided by 6. So S is equal to 2 pi divided by 6, which is equal to pi over 3. So when theta is equal to 60 degrees, S is equal to pi over 3. Now I just want you to consider those 3 angles and their corresponding arc lengths, because we might be able to see a pattern and carry on from there. So 90 degrees, we've got pi over 2, which is this one over here. 180 degrees, I've got pi. 60 degrees is equal to pi over 3. Here's the new idea, is that when we've got a unit circle, then instead of talking about degrees, for example, I've got 60 degrees sitting in this circle over here, I can actually replace that, and instead of saying 60 degrees, we can say my new angle now is equal to pi over 3. So we're just replacing the degrees that we've normally got with kind of with the arc length. And that actually is what we call a radian. So and a radian can be defined that when I've got a unit circle with a radius of 1, then the arc length is exactly the same as that angle. And so here, the angle in radians is pi over 3, which is the same as the length over here. So let's have another look at another situation. So if we just remove that, we'll go back to, we had change colors as well. So we had 90 degrees over here. Right, so this is 90 degrees there, and my arc length when is 90 degrees is pi over 2, so S is pi over 2. Therefore, when I've got a unit circle, then that angle now in radians is pi over 2. So you can see there's a corresponding, there's my angle, pi over 2. There's my arc length, which is also pi over 2, with the condition that the radius is equal to 1, and that's very important. So now that we know that, so we've got a new kind of angle measure here called a radian, we can go and have a look. I've got another unit circle here. I'll just move that, I'll try and move that up a bit. Behave, come back, come on. We'll shift that up the screen. There we go. Now it's behaving. And what we're going to do is put some different angles on here. So I'll make that just a nice little bit larger. So we've already worked out 90 degrees, therefore, is equal to pi over 2 radians. Okay. 60 degrees, therefore, is pi over 3 radians. 180 degrees, therefore, is equal to pi radians. We can carry on. And if I've got 45 degrees, well, that's half of 90, and that's equal to pi over 4. 30 degrees is half of pi over 3, which is pi over 6. And we can end up with a full circle. So we're kind of replacing all of that, realizing, okay, so let's just build that up, that 2 pi, actually I'll word that in a slightly different way. If I've got 360 degrees is 2 pi, so they account to a full circle. Remember, again, that relates to the arc length when we've got a unit circle with a radius of 1. 180 degrees is equal to pi. 90 degrees is equal to pi over 2. 60 degrees is equal to pi over 3. 45 degrees is equal to pi over 4. 30 degrees is equal to pi over 6. And we can work out all sorts of others, because if we know, typically if I know that one, then the rest follow suit. So you can see that 90 is half of 180 divided by 2, and so on. So 60 is 1/3 of 180, therefore it's pi over 3, and so on. So that's the new angle measure, radian.